Do you know that quadratic equation has many real-life applications, including determining surface area and volume of a spatial object, the speed of a moving object, the profit of an investment, and even the trajectory of a space rocket? Quadratic equation holds a unique position in the school curriculum. This quadratic equation series will not only provide you the basics, but also equip you with the skills to solve advanced quadratic equations so that you can achieve greater math results in school. Welcome to the first part of this series. In this video, we will learn to use the cross product method, completing square method, as well as the quadratic formula method by solving 3 examples. Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything. Hello, welcome to the series of quadratic equation. This is the first session of this important topic. The first question is why we need to present this quadratic equation topic. Why the skill of solving quadratic equation is important? Well, quadratic equation is one of the most fundamental theorems in algebra and other mathematical fields. Quadratic equation is often used to model physical things or natural phenomena. In addition, it holds a unique position in your school curriculum. Now, we are going to demonstrate various skills to solve quadratic equations in this series through worked examples. The first example here is to solve a quadratic equation of 6x squared plus 7x plus 2 equals 0. Here we are going to show 3 common approaches to solve this quadratic equation. So I hope you will learn and consolidate these skills after this session. The first approach is the cross product method. In this approach, we listed the factor pairs of the quadratic term 6x squared and the constant term 2. Here there are 2 possible factor pairs for the quadratic terms x and 6x, 2x and 3x. However, there's only one possible factor pair for the constant term, which is 1 and 2. The next step is to select the combination and test if the middle term can be matched. Here we just show the correct combination, which is the factor 3x cross times 1 and the factor 2x cross times 2, which produce the middle term 7x. After factorizing this trinomial quadratics, then the null factor law is applied to solve this quadratic equation. And we find x equals negative 2/3 or negative half. The second approach is to use the completing square method. Since the quadratic coefficient is not 1 but 6, so we take the 6 out, just like taking out a common factor as shown in the display. Then the equation becomes 6 times the quadratic trinomial in parentheses. The next step is to add a constant, which makes x squared plus 7x over 6 a complete square. You may recall the constant we need is half the linear coefficient, then squared. In this case, it is 7 over 12 squared. After combining the constant terms, it is equal to 1 over 12 squared. Now, the left-hand side of the equation is exactly the difference of 2 squares, so that it can be factorized using the formula of the difference of 2 squares. Therefore, the solution of x can be obtained, which is negative 2/3 or negative half. The last approach for solving this equation is to use the quadratic formula method. In this approach, we need to check the discriminant of the quadratics and see if it is greater than or equal to 0. Otherwise, there's no real solution can be obtained in this equation. As we have already learned, the discriminant delta equals b squared minus 4ac, in this case which is 1. Therefore, the formula of the quadratic equation can be applied and give the solution of negative 2/3 or negative half. Question 2 is to solve a quadratic equation which is similar to question 1. Like previous question, we still use 3 common methods to solve this equation here again. As for the first approach, the cross product method, you need to list all the possible quadratic factor pairs as well as those of constant factor pairs. Then try various combinations and see if the linear term can be matched. Here we just show the right combination which produce the linear term negative 5x. After the null factor law being applied, 2 solutions for x are obtained. They are negative half or 3. As for the competing square approach, after taking out the quadratic coefficient 2 and then add a constant term of 5/4 and then squared to make x squared minus 5x/2 a competing square. After combining the constant terms of negative 5/4 and then squared minus 3/2, we have 49/4 squared, which equals 7/4, or in parentheses squared. Since the left-hand side of the equation becomes the difference of 2 squares, it can be factorized and 2 solutions of x can be obtained by applying the null factor law. It is negative half or 3. The final approach we are going to show here is the quadratic formula method. Like we did in question 1, the discriminant of the quadratic equation needs to be calculated. That is 49 in this case. It means there are 2 distinct real roots for this quadratic equation. Then the formula of the quadratic equation can be applied, which enables us to obtain 2 solutions, negative half or 3. Question 3 is a fractional equation with square root form. The first step here is to cross-time the fractions on both sides of the equation and then rearrange them. The equation is simplified here in its new form, which is negative 3x equals 8 square root of the sum of x plus 1. Since square root of the sum of x plus 1 must be greater than or equal to 0, and at the same time x plus 1 is also greater than or equal to 0. Therefore, the solution of this equation must be in the range of negative 1 and 0. We square both sides of the simplified equation and obtain a quadratic trinomial form of 9x squared minus 64x minus 64 equals 0. Here we solve this equation by using the cross product method. As we remember, list all the possible quadratic factor pairs as well as those of constant factor pairs, and then try various combinations of these pairs and see if the linear term can be produced. Here we just show the correct combination, which produces the linear term of negative 64x. Therefore, 2 solutions are obtained for this equation. It is negative 8/9 or 8. Since x must be in the value range of negative 1 and 0, so there's only one qualified solution exists here, which is negative 8/9. As for the other two approaches, the completing square method and the quadratic formula method, you may try them out yourself and see if you can get the answer correctly by applying these two methods. If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.